Everyone, let me know if I'm audible, guys. Before time, yes, finally. Let me know if I'm audible. Am I audible, guys? Can someone? Yes, I am audible. Am I audible, guys? Can someone? Looks like say. Let's wait for everyone to join in. We are super fast today. We are before time. Express is running before time. Waiting for everyone to join in and then we'll get started. Just a couple of minutes till everyone joins in. How's everyone? How's been weekend? Weekend कैसा रहा सबका? How's it been? Leetcode कर रहे थे. बढ़िया. भैया VMware या Amazon can be anything. Depends. Personal choices. I won't comment on personal choices. Thank you, बंद हो गया. चल जा भाई. दो में चलेगा, एक में नहीं चलेगा फैन. Sick, Parag. Why sick? So the topic will definitely be Leetcode 270 solutions. Let me just place everything in a corner so that I can get everything sorted. ये रहा sorted. मेरा WhatsApp is here for an emergency purpose. छोटा करते हैं WhatsApp को. Chat box कहाँ है? Chat box यार लाइक कर दो, स्ट्रीम को लाइक कर दो. ठंड लग रहा है यार, फैन बंद करो. बिना फैन के स्ट्रीम करेंगे. गूगल का एक्सपीरियंस कल आ जाएगा, कल सुबह. Tomorrow I'll get the experience. Stream like kar do. So the topic name is Leetcode 270 Solutions. Okay, 270 Solutions. Going across, if anyone is new over here, and to give an introduction, my name is Raj Vikramaditya. I'm known as Trevor in the programming community. I'm a competitive programmer, or I was a competitive programmer, whatever you wish to call, you can. I am a software engineer at Currently, I'm a candidate master at Codeforces. Also, I'm a 6-star rated coder at CodeChef. I've been teaching from the past couple of years. Also, I run a YouTube channel which has around 125 plus subscribers. The subjects that I primarily take are competitive programming, data structure algorithms, C++, interview preparation, and going across. A lot of times candidates like you miss out on great opportunities due to multiple reasons. It might be that you don't have a great degree, or you don't have a great connection network, or a lot of seniors who work in great companies. So, and it also might happen that you are applying to a lot of companies but you are not getting shortlisted. So that is when something like Relevel comes in, which is India's first test hiring platform backed up by Unacademy, which is helping job seekers find their dream jobs. Now you can get a job on the basis of your skills and talent. You need not depend on any degree or anything. Okay? Now, benefits of participating in the Relevel test are there are over 50 plus companies, including India's top startups and unicorns like Red, Razorpay, Upgrad, 1MG, Zoomcar, etc., where there are across 1,000 plus job openings, business development, front-end development, back-end development. You can attend this test for free. It's absolutely free. If you fail on the first attempt, you can re-attempt that after 30 days. So within the interval of 30 days, you can keep on re-attempting. So registering on Relevel is very simple. Once you have registered, you give the test, you pass the cutoff score. Once you have passed the cutoff score, you can apply to the companies on their side, and then the interview will be scheduled, and if everything goes fine, you will get your offer letter within 15 days. And there are 4 categories. I'm not sure why they have not updated the presentation, but yeah, there are 4 categories along with these 3 categories like business development, front-end development, back-end development. There is a category like data analytics. Now you can book a slot whenever you want to give the Relevel test. Slots are limited, so I'll recommend you to suggest to book it as soon as possible. Now you can use my promo code, which is STRIVER Striver. You can use any other educator's promo code to get the free sample paper right before the mock test, because before giving the mock test, it's very important that you check out the sample paper. So what are you waiting for, guys? Please make sure you check out Relevel. And also, if you haven't joined the Telegram group, please join it. The link will be in the description. You can also join my Telegram group, which goes by the name Take You Forward, so that I can update you whenever I'm taking a live stream or whatever I'm doing. Okay, perfect. शुरू किया जाए. थोड़ा सा इसको सेट कर देता हूं तब तक. ओके, वीकली कॉन्टेस्ट, ये वाला कॉन्टेस्ट अपन करने वाले हैं, तो इसको मैं फटाफट सेट करता हूं. रुको, हाँ, सेट हो गया. Okay, so let's do the first question on the day, which is definitely easy. Okay, so done across. Okay, finding the 3-digit even numbers is the question. So I'll recommend you to go through the question, and once the question is clear, give me a UQ. I don't play chess. I used to play chess. No, the SD sheet is purposely for interviews. For coding assessment, you have to give Leetcode contest and all to get better and better. Okay, please go through the question and let me know UQ in the chat the moment you understand the question. UQ in the chat the moment you understand the question. Okay, UQ in the chat. It's kind of similar. Leetcode contests are kind of similar, but yeah, probably I'll recommend you to do Code Forces if you are not able to crack online assessments. That will give you a much more clear idea about how problems are in online assessment. But again, then for companies like Amazon, Microsoft, and all these, you will not be requiring. चेक क्वेश्चन पढ़ लो फटाफट. आज पूछ लो जितना पूछना है. कल से you are not allowed to ask any interview related stuffs. Okay, I've updated that in the Telegram group. Going forward, I'll just be teaching DSA. So yeah, enjoy my problem solving skills. Don't ask me any interview related, how to crack interviews and all these stuffs. I've already told that a lot of times. I'll be focusing on interviews and yes, Abhishek, you can start my SD sheet. If you have done DSA basics, you can start the SD sheet. How do I identify DSA related questions? So I have a masterclass on the Christmas ke din, which is 25th of December. I've kept a masterclass from 2 o'clock to 6 o'clock, where I'll be telling you how to detect DSU problems, and I'll be solving a bunch of DSU problems. So yeah, join on 25th December to know more. Okay, UQ, please. Citizen watching, I think people are yet joining in. 81 watching, fine. Please read the question super quick. Question पढ़ लो, शुरू करते हैं. UQ, everyone UQ. I might from now onwards, I might come at 9:30 for some days. 9:30 पे आ सकता हूँ, 9 बजे आ सकता हूँ. So yeah, keep a tab on, like have the notifications on. Specifically, I'll be coming live on Saturday, Sunday, and Wednesday. These 3 days I'll be coming live. Yes, if I have something planned for myself, then probably that Sunday might be Monday or Tuesday. But specifically Saturday, Sunday, and Wednesday is when you can expect me over here. Like it's a proper routine. Yeah, I might कोई शादी वगैरह में जा रहा हूँ, या फिर if I have something, then I might miss out. But yeah, I will make sure that I continue this trend of Saturdays, Sundays, and Wednesdays. Okay. Cool. So let's read the question. What does the question states? The question. Oh, एक second to go. Okay. The question क्या state करते हैं? The question states here, given an integer array digits, I'll be like, okay, that's perfect. Where each element is a digit, the array may contain duplicates. So you're given an array where there will be a lot of digits and there might be duplicates. Okay, you need to find all the unique integers that follow the given requirements. Now the integer consists of a concatenation of 3 elements from digits in any arbitrary order. The integer doesn't have leading zeros, okay, and the integer is even. Like for an example, if I check this array out, you have been given with digits like 1 2 3. Yes, you have been given with digits like 1 2 3, and the integers that you can form is, if you pick this 1, if you pick this 3, if you pick this 2, then you can form 132. If you decide that you're gonna pick this 3, then this 1, then this 2, then you can form 312. And I don't think you can form any other numbers like 123, numbers I will just give you a proper numbers like 1 2 3. This does not follows this particular condition, which is the integer is even, thereby this is not allowed. Hence you can just make these couple of stuffs. So this is what the question states. So if I ask you a simple question, how will you do this problem? How will you do this problem? 3-digit numbers. Again, something very important to mention, the concatenation is of 3 elements. So all the digits, all the numbers that you will see will be of 3 digits. Now the first approach that specifically comes to my mind is, okay, given all the digits, probably I can try out all combinations and do it. But again, that's not a possible solution because the length is 100. So if I am going to try out all possible combinations, it might end up giving me a problem. But can I say without checking the all subsequences, do I have a better way? And yeah, this gives me a hint. It says return a sorted array of unique integers, like the smallest one should appear first. Now can I say, if I'm talking about 3-digit numbers, yes, if I'm talking about 3-digit numbers, I know the number starts from 100 and goes till 999. Can I say this? The number starts from 100 and 999. Like all the 3-digit integers are bound to lie between 100 and 999. Correct. So if they are lying between 100 to 999, I just need to check for in between this number. If I'm taking something like 114, what I need to check is, in this given digits, yes, in this given digits, does 1 appear twice and does 4 appear once? If this is possible, then this 114 can be created. So in this way, can I check all the numbers from 100 to 999? Basically, I take a number and I see if the frequency is available in the digit array or not. If it is available, I'll say this number can be formed. Does that make sense? Does that make sense to everyone? Does that make sense to everyone? Everyone? Has everyone got this? Everyone? What I'll do is I'll take every number from 100 to 99. I'll pick up digits from them. I'll check if they're present in that or not. Okay? You don't need to do anything else. It's an easy one, right? So if I'll code this and then I'll also tell you how to code it. Very simple. So I can say I have a vector where I can store all the answers. Correct? I have a vector where I can store all the answers. Now I definitely need a map. So probably you can store an unordered map or whatever you wish to. So these are digits. Okay, so probably you can keep int frequency of 10 size, and then you can put a 0 over here, and then you can be like for for auto of it of digits. Okay, ring light go. Digits, and then you can be like frequency of it and then a plus plus. So once you have done this, you know your answers are going to lie from int I equal to 100, I lesser than 99, last one will be 998, and I plus equal to 2, because we are just looking for even, numbers. Okay, thereby now what I can say is, okay, that's fine. Can I say if check I with this frequency, if it is possible, then this will be stored in the answer. Okay, perfect. This will be stored in the answer, and at the end of the day I can definitely return the answer. Now what I just need to write is the private function which says can you just keep a check with the integer number and int frequency, and then what you can do is, okay, this is fine. So while okay, so something to understand is we need to check the frequency of every number. Correct? So probably we can keep one more frequency 2 2 as 10 equal to 0, and what I can do is while a number, I'll iterate on the number like this, and I will like, okay, frequency of 2 num modulo 10 plus plus, and I can do num equal to num by 10. Okay, and at the end of the day, what I can do is I can simply check if all of them are equal or not. Like I'll just simply check if from the digits like 0 till 9, like if frequency I exists, yes, if frequency of 2 of I exists, and frequency of 2 of I is by chance greater than what you have with you, then it's not possible. Because you need at least equal to or greater, so or else it will be true. I think this should be perfect. Java C++ क्या होता है dude? Java C++ क्या होता है? मतलब ये क्या है? मतलब instead of vector use an array list in Java, that's it. Apart from that, I think everything is similar. In Java also you write while loop, in Java also you write for loop, isn't it? For everyone who's saying Java, I think you will never survive in the industry. The moment you get into the industry, there will be a lot of stuff. Now if you can't understand this function, I can't help, because in Java also it's exactly the similar. Even if I write it in Java, क्या ही होगा vector के जगह, it will just be a list, right? Array list. Over here it will be iterating over that, so you can use an int I to iterate. So how is it different, man? See, if you're still crying between C++ and Java and you're not understanding a line of code, and trust me, you're gone. Learn to adapt, man. Learn to adapt, right? So Java C++ क्या है? Logic is very simple. You iterate from 100 to 998 and you check. That's what you do. As simple as that. Okay? So I'll just submit this and check. Okay, so has everyone understood this? But this is a very longer piece of code. I can still make it short, but I'm just asking you, have you understood this, so that I can give you the shorter piece of code? ये तो normal what comes to your brain, that okay, let's take another frequency array, check it. Can you give me an US? Why big array size? Because it's talking about digits, right? It's talking about digits. Digits will always be between 0 to 9, so it will work, right? Okay, everyone has understood this? Come on, stream like कर दो. Let's make it 100 likes. 200 likes target करते. Let's target 200 likes, guys. Roadmap of competitive programmer is already uploaded. Please check that out. Okay, so everyone has understood. Perfect. Now can I make this code short? Yes, I can. So what I'll do is I will say that, okay, I know one thing. If I write down all the integers, it's like I have 3 places to fill, right? I can say I have exactly 3 places to fill, and I know this place can be filled. Since a number cannot start with 0, I know this place can be filled with digits from 1 to 9. This place can be filled with digits from 0 to 9, and this place can be filled with digits from 0 to 9. Do you agree that there are 3 places, and these 3 places can be like one, like the first place can only be from 1 to 9 because the number cannot start with 0. The second place will be from 0 to 9, agreed, and the third place can be from 0 to 9. Now can I say I can run a for loop easily, where the first for loop runs from 1 to 9, the second for loop runs from 0 to 9, the third for loop runs from 0 to 9 again, and that will generate all the possible combinations. So I'll show you that so that you can get a fair bit of idea. So if I just write I equal to I, and if I just write this, just I'm teaching you how to generate, nothing specific. int j equal to 0, like this will generate all the 3-digit numbers to be specific, which starts like I'm just trying to teach you how to write a short code, nothing specific, कुछ ऐसा special नहीं है, just teaching you how to write short codes, because these things, see, if you अरे यार क्या हो गया, Yeah, last one should be even, that we'll see. So if you see, all the numbers are generated. See, I generated all the numbers. Do you see? So this is a very interesting way to generate all the numbers also. In this way also you can generate all the numbers. Okay, so now I know one thing, the last number will be, the last digit has to be even. So I can say it will be from 0 to 8 and k can go as plus equal to 2. Now if I run this code, this will generate all the even numbers, because this will definitely be from 0 to 8. Okay, makes sense. Now what do I want? I know one thing, I need the frequency. So probably I'll keep a frequency of 10 again, and I can be like equal to 0. Okay, that makes sense. That does make sense. Now I can say that I'll again iterate across the digits, and I can be like frequency of it plus plus. Okay, so right after this, can I say over here I need to check if the frequency of I exists. Then only I can consider this I as the first digit. Do you agree with me or not? I need to check if this I can be considered, considered as the first digit or not. Agreed? That means I have to check this. Now over here you will be like, okay, then just check frequency of j. But is it correct? No. Why? Because what if edge case is I is 1 and j is 1, which means the I is equal to j, thereby frequency value should be a minimum of 2. Agreed? So can I say frequency of 2 should be greater than if I is equal to j? That means if I is equal to j, then it means 1. Frequency should be greater than 1, right? Then it will work. And over here, can I write and frequency of k should be greater than I equal to j, and if both of them are equal, then it means, yes, then it means that it's an edge case of something like I equal like 1 1 1. This is the edge case, and if this is the edge case, then I know this is 1 plus this is 1. So frequency of should be greater than 2. So I'll easily check if frequency is greater. I don't need to do any plus plus or minus minus. Got this? Did you get this? I'm not doing any plus plus or minus minus. Does that make sense, everyone? Does that make sense, everyone? Does that make sense, everyone? Frequency of I, frequency of j. Everyone has understood this. Has everyone understood this? Now, if this is the case, then I can definitely store the answer. Could not understand? Who cannot understand? So I into 100 is the first digit, j into 10 is the second digit, and then you can just pass on k. Should work. Okay, you need to okay, how many of you did not understand? How many of you did not understand? अरे ये क्या हो गया? कुछ गलत हो गया क्या? Just a minute. Give me a moment. I think I messed up somewhere. Let's see. I into 100. That's perfect. J into perfect. Frequency of I. Frequency of it plus plus. This is perfect. Frequency of I तो होना ही चाहिए greater than 0. Should be greater than 0. Okay, perfect है. I plus plus. I equal to j. सही है. H case भी सही है. K plus equal to 2 भी सही है. Okay, so what am I generating? 100, 200 and 300. Okay, looks like it's not going in for certain values. Let me check that. Super quick. Anyways, oh ho. नहीं ये तो सही है. बीच में प्लस होगा. Yes. Thank you. अभी मैं वो पढ़ाया था. कोई नहीं, अभी भी एक ईशल ले नहीं रहा एक साथ। 210, 212, 102 क्यों नहीं जनरेट हुआ? 1 गया, 0 गया। I'm checking frequency of j should be greater than I equal to j. Okay, why did it not generate? Should be plus plus. Yeah, I've done that. Let me just give me a moment. I'll check this off. क्यों नहीं हो रहा है? I guess for loop में just give me a minute. I'll check this off. क्यों नहीं चल रहा है? तो 1 जा रहा है. फ्रीक्वेंसी ऑफ 1 चेक हो गया, फ्रीक्वेंसी ऑफ जे भी चेक हो जाएगा। जे आई इक्वल टू अगर जे है तो फिर एक साथ चेक कर लेगा, वो चलते जाना चाहिए। अगर के इक्वल टू 8 है तो के प्लस इक्वल टू 2 मारेगा, आई इंटू 100 करेगा, प्लस जे इंटू 10 करेगा, प्लस के करेगा, ये प्लस के करेगा। हाँ, वर्क्स फाइन। फ्रीक्वेंसी ऑफ जे लुक्स लाइक ये एंड नहीं काम कर रहा है क्या? Frequency of IT plus plus digits पे with answer or pushback. Why the hell this is not coming? 102 की नहीं है, 1 गया 0 गया। Let's check this out. See what if 10 frequency next loop में आएगी। ओह हो 1 नहीं सही तो है यार। आई इक्वल टू के, अरे सेम ही तो है यार। जे इक्वल टू के, आई इक्वल टू के तो सेम ही है। सेम ही तो दोनों नंबर्स है ना। रुको क्यों नहीं जा रहा है अंदर में? मुझे सोचने दो। अगर मैं आई लूँ, जे लूँ, कुछ तो मैंने गड़बड़ लिखा है, इसलिए नहीं जा रहा होगा। कुछ तो गड़बड़ लिखा है, रुक जाओ। Okay, this loop will break if I am to think, will this work? Okay, this doesn't work. This doesn't work. The loop will break. Correct. The loop will break. So we can make it easier. We can say we'll only consider j. We can write the j case here. We will only consider j जब ये बंदा इक्वल हो, क्योंकि k में अच्छा j का लूप ब्रेक हो जाएगा। करेक्ट। तो अगर मैं कहूँ कि मैं फ्रीक्वेंसी ऑफ j कंसिडर कर लूँगा, अगर इस केस में i इक्वल टू j हुआ, सही है, तो j का लूप नहीं ब्रेक करेगा। एंड यहाँ पे आई कैन राइट द सेम थिंग दैट आई रोट, फ्रीक्वेंसी ऑफ k should be greater than I equal to j, I equal to k plus j equal to k. Yeah, now works fine. If I'm saying this, then it will work. Yeah, अब चलेगा। It was, the loop was breaking. Yeah, the loop was breaking. So basically what happened was we put over here. So अगर एक j के लिए नहीं करेगा तो आगे का j का टेस्टिंग ही नहीं होगा, which was the case. Anyways, we'll check this off एक बार। If I equal to j, output expected, क्या हो गई आउटपुट? नल क्यों आ गया इसको? अब ये भी नीचे चला जाएगा, यहाँ पे आ जाएगा, तभी कंसिडर करेंगे इसको जब, हाँ अब चलेगा। चलिए, perfect. So basically what happened was, see, we'll only consider this I as the first digit if it exists. We'll only consider this j as the second digit if it exists greater than I equal to j. Why greater than equal to I equal to j? I'll tell you. अभी assume करो ये I 1 है, ठीक है? Assume I is 1, j is also 1. So both of these are 1, okay? So you can only consider, like, 1 will be considered at the first position, but on the second position 1 will only be considered if the frequency is I equal to j, मतलब बराबर है तो ये क्या होगा 1, फ्रीक्वेंसी की वैल्यू 1 से ज्यादा होनी चाहिए, तो बेसिकली 2 या 3 या 4 ऐसा कुछ होनी चाहिए. दैट्स व्हाई रिटन अगर बराबर है तो उससे मतलब 1 से ज्यादा होनी चाहिए उसकी फ्रीक्वेंसी, तभी हम इसको दोनों जगह पे कंसिडर कर सकते हैं. गॉट इट. नाउ व्हाई एम आई सेइंग अगर 3 बार है वो और एक केस आता है. व्हाट इफ इट्स ट्वाइस, this is 1, this is 1 and this is 1, then we can only consider it on all the 3 places if the frequency is greater than 2. The frequency has to be minimum of 3 of, like 1 should appear thrice. That's why I equal to k, ये 1 देगा, j equal to k, ये 1 देगा, 1 plus 1 क्या देगा 2. So frequency of k should be greater than 2. Now understood everyone? Has everyone understood now what I did by using these values? Has everyone understood this, what I did by using these values? Yes, now I'll move to the next one. If you have understood this, it's an easier version. Like if you want to write it, it's 3-liners. अब तो समझ में आ गया होगा, right? Should be clear now. I'm basically checking if it exists or not. That's it. Okay, perfect. So simple one, 3-liners. So we are done with this. We'll move to the next one. We're done with this. We'll move to the next one, which is delete the middle of the linked list. It's an easy question actually. It's a very famous question of tortoise and how method, if you know this. So read the question super quick. Then we'll do this. Question को फटाफट पढ़ लो. Read the question super quick. Then we'll do this. Any solution you generally I prefer writing shorter quotes. Is it lagging? No, I don't think it's lagging. No, it's not lagging. No, it's not lagging. Last वाला करूँगा last वाला करूँगा. By the way, guys, is it lagging? Just can you just give me a confirmation if it's lagging? I don't think it's lagging. Is it lagging? No lag ना. हाँ सही. Okay, perfect. Your voice is breaking up. नहीं भाई, तेरा इंटरनेट ब्रेक कर रहा है. वाईफाई का पैक बढ़वा ले ब्रो. ऐसे ज़्यादा मैं क्या लो भाई. It's already 215 Mbps. इस पे लैग नहीं करेगा ब्रो. It just requires 10 Mbps to stream properly. Okay. Read the question. Let me know if it's understood. Voice is breaking. Let me check it. Okay. Read the question. Let me know if it's understood. Voice is breaking. कहाँ ब्रेक हो रहा है भाई? Let me check it. एकदम ब्रेक नहीं हो रहा है. क्या बोल रहा है? UQ if you have understood the question. UQ if you have understood the question. UQ if you have understood the question. UQ please if you have understood the question. Everyone give me a UQ if you have understood it. Everyone knows fast and slow pointer. So I already have a video on this, how to find the middle node of the linked list. It goes by the tortoise and harm method. If you follow the tortoise and harm method, you can do it very simple. So basically what tortoise and harm method does is, if this is the linked list, like basically let's understand the question. You're given the head of the linked list and you need to delete the middle node and return the head of the modified linked list. So specifically speaking, it's kind of in this linked list, this is the middle node, so you have to delete it, and this link should point here. So this is the change that you have to do. And if you return this particular link list. Okay, now if I just go across to the down for this guy, if there are even number of nodes, then the second middle will be considered as the middle. So this is the middle. Okay, and you will break this node. You will basically take this and point it to here. That's what the question states. So this is deleted, and if it's a single node, then you can just delete the single node. If it's a single node, you can just delete the single node, but I am assuming it will not be a single node because I think they have clearly stated over here. Okay, it can be a single node. Okay, works fine. So how will you solve this problem? One of the easy methods is definitely first iterate and count the number of nodes. Like over here, I think the number of nodes is 7. So one iteration will give you the number of nodes. Basically, you do like 1, 2, 3, 4, 5, 6, 7. You basically do 7 iterations, and you say the number of nodes is 7. And then you do 7 by 2, and you say it's 3. So again, you do something like 1, 2, 3. So you come across to the third node. Now, once you're standing at the third node, you say, hey, you point over here, which is basically something like saying yours next should be pointing to, like yours next should be pointing to something like next of next. So that will easily break down. Yours next should be pointing to next of next. That will break down the node. But this method will be taking a lot of time because first you have to find the total number of nodes. That will end up taking big of n time. Then again you have to do an n by 2 iteration to again reach this particular node, and then you can break this particular node. So that is not a probable solution. That's where have you understood this easy approach? Have you understood the easy approach? Easy approach समझ में आ गया क्या सबको? Yes or no? Has everyone understood the brute force of big of n? Count the number of nodes, find the middle, and go and stand there and just do your job. Okay, so everyone has understood the easier method. Okay, so obviously the easier method can be done in Leetcode, but when you are जब तुम शादी करने जा रहे होगे तब तुम नहीं कर सकते ये चीज, राइट? जंग बोलते हैं. अच्छा मैं जंग बोलूंगा इंटरव्यू को. सो बट जब तुम जंग लड़ने जा रहे होगे, व्हेन यू आर इन अ वॉर, यू कैन नॉट टेल दैट बिकॉज देन दे विल किल यू. So what do you need to do? That's where something like a slow and fast pointer comes in. So there's a method known as tortoise and hare, which says, okay, I'll keep 2 pointers where I'll keep a slow here, I'll keep a fast here. And on the first step, I'll say slow, can you move from 1 step? And I'll ask the fast to move by 2 steps. That's the first step that I'll do. Next, I'll be like, slow, move by 1 step, fast, move by 2 steps. Next, I'll be like, slow, move by 1 step, fast, move by 2 steps. So the moment I reach the last node or I am reaching the end, I stop. So you see that you're standing at the slow pointer. So while you were moving, you could have kept a track of slow, like the previous node, and then you can easily point this. So this is how you find this middle node. And this is how you find the middle node. Basically saying you move the slow pointer by 1, and then you say the fast pointer to move by twice. Okay, so that is what you can do it. If you just move by slow by 1 and fast by twice, that will be done. But you are again using a previous pointer. Let's understand. तुमने slow रखा, फिर तुम slow को बढ़ाया, but you're remembering what is the previous, because whenever slow reaches here, this is going to be the middle. Because whenever slow reaches here, this is going to be the middle. But you need to remember 4. You need to remember 4 because 4's next will be pointing. Like you have to break the node. So you have to remember the previous. So if you have to remember the previous, there is still a scope of improvement. But I'll still code this. But I'll teach you how can you do this using just 2 pointers. I will not be using a previous. I'll be teaching you using exactly 2 pointers. But as of now, has everyone understood the slow and fast pointer concept? The intuition is very simple. एक बंदा अगर 2 गुना भाग रहा है, if someone is running at the twice speed of me, whenever he completes the distance, I'll definitely complete the half of the distance. Simple intuition. Okay, so right, so since everyone has understood this, so what I'll do is I'll quickly code this. So list of node stars slow can be kept as head. Okay, list of node of star fast can be kept as head, and then you can be like while fast dot next is not equal to null, and I think this should be fine. Should be fine. Okay. Fast and yes, fast dot next should be fine, and you basically keep the track of the previous as well. So you can be like list of node dot previous equal to head, and what you can do is you can say okay, previous is going to be slow, and right after this you can be like okay, now just move the slow equal to slow next. Then you can be like let's move the fast equal to fast dot next, and once you've done everything, fast दो बार move करेगा, so fast dot next. Once you've done everything, you can say previous next. Can you point to previous next ka next? That's a like I used simple one, and yeah, you can just return the head of the linked list, which I think you need to return the head of the linked list or what? Yeah, return the head of the linked list. So definitely you can return the head of the linked list now. That's a simple one. So I'm not sure if this will work. चल जाएगा. Member accessible क्या होगा इसको? Yeah, as I expected, single node पे issue करेगा. As I expected, single node पे issue करेगा. If I have to put in, can I in इसी पे कर सकते क्या? Can I do this over here? If previous is head, previous next. Can I do this over here? No, let's keep it null. If I keep the previous as null, then I'm saying null next, which is again wrong. So if I say previous is equal to null, then I can definitely return. That's why when I started, I checked what's the constraint. If you remember, when I started, I checked if it's a one node, because I was expecting this will fail here. Anyways, should be fine now. Yeah, should be fine. So yeah, I said, when I started only I checked for the edge case. As a computer programmer, whenever I start, I check with constraints. So I found, like, I had this in brain ki agar nahi hoga to nahi chalega. So yeah, this is something like, okay, fine. If it's a single node, it still works because you're returning null. This is the simple one. Has everyone understood this? This is a 3-pointer approach where I'm using a slow and a fast and a previous. Has everyone understood this? जंग में ऐसे एक एलिमेंट को कैसे लेके रोएंगे क्या? नहीं. Okay, has everyone understood this? Has everyone understood this? Everyone? Yeah, you could have done previously also. That's your choice. That's your choice. You could have also written something like this. If head dot next, this is also correct, is equal to null, then you return a null. This is also correct. That's your choice. It's okay. As long as you're solving it, it's okay. It doesn't matter. Okay. So has everyone understood this? US please. US please. US please. Everyone. Okay. Now you're using couple of pointers. So 3 pointers. Now I'm expecting you to use 2 pointers. So how will you do this? That's a good question. How will you do this? How will you do this particular stuff using 2 pointers? It might feel an easy question to you. Yeah, it might feel an easy question to you. But it's actually not an easy question. Basically, a lot of people don't know about the tortoise and the hare method. They basically do is they traverse, find the length of the linked list, then they half it, then go to the half, then they delete it. So everyone can do this. So what if I can stop over 4? What if I stop at 4? Like as of now, what is happening when I'm doing the slow and fast? Slow is stopping here and fast is stopping here. What if I can do something where my slow stops here, like right before the middle? So what I'll do is I'll say, okay, slow, let's do one thing. uh, you are standing here. Okay, you are definitely standing here. But for fast, what we will do is we will tell him to stand here. I'll be like, does that make sense? Yes, it does make sense. It does make sense. Now, the initial configuration that I have stated, instead, like I just modified the initial configuration. Prior to this problem, the initial configuration was slow and fast right at the head of the node. Now, what I've done is I've modified the initial configuration and I've said, hey, slow, can you please stand at 1, and fast, can you stand at 4? I'll be like, okay, that's perfect. And then I start moving slow 1, fast 2. Then again I move them slow 1 and fast 2. Now, if I do this, then I will end up standing at 4, and I don't need to remember previous. So I'm eliminating a single previous stuff, which is if you're going to a war, then in that war, people will be very critical about this one. Like you might feel, what have you done by just eliminating one variable? But if you're going to a war, then over there it's very important. I hope you get this, right? So this slow, like if you just make sure that this happens, now you might be thinking, what about edge cases? Okay, even if I take this case, I'm having slow here and I'm seeing fast here. So the first step, slow goes here and the fast goes out. Perfect. Slow again stands at 2, so you can just break it down. This will point here. It still works. So it will work for odd as well as even. So we just need to make sure that the initial configuration, is changed to next dot next. And what I can do is obviously I'll keep it for this one. If head dot next is equal to null, then we can definitely return null, that's for sure. And yeah, over here what you can do is you can just eliminate previous this time. Yes, you can eliminate previous and the same thing will happen, but instead of this, the slow pointer points at the correct position now. So you can just run it like this and this is going to work. If you see, this is going to work. So I eliminated one pointer, and not a big deal, but yeah, in an war it's a very big deal, right? Has everyone understood this? So if no one knows about how to find the middle of the linked list, go to Take You Forward. There's a proper video of intuition and everything. You will get to know. Okay, US. So in this way you can do it. So it's just a minor shift. Now how did I come up with this solution? I was solving this. I thought that okay, slow इधर रुक रहा है, मुझे एक ही तो आगे रुक. I just have to stop it one step back. Okay, if I have to stop it one step back, which indirectly means fast को शुरुआत में एक स्टेप आगे बढ़ा देता हूँ ना. अगर फास्ट जब स्टार्ट कर रहा है तो एक स्टेप आगे है, तो वो जब एंड करेगा मैं एक स्टेप पीछे ही एंड करूंगा मिडिल से. कॉमन सेंस लगा के करे. You can use the common sense, right? Yes, war में एक पॉइंटर से फर्क पड़ेगा. Thank you दीपक, thank you. Okay, like, share, subscribe. Next see you on Facebook. ज़्यादा हो गया भाई. I have to do PhD for that. PhD वगैरह करना पड़ेगा. I'm not interested in studying any further. I'm done. Why have I written this thing? Because it might happen you are standing at the last guy, so no need to do it. That's why this is written. Please watch out the finding middle of the linked list video. If you don't know how to find the middle of the linked list, please watch out finding middle of the linked list on YouTube on Take You Forward. Okay, what I've had, no, it cannot be now. Look at this. The number of nodes in the list is in the range 1. Like it's assured that the number of nodes in the linked list will be 1. So how can the head be null? How can the head be null? Yeah, I go through a lot of solutions. I go through a lot. Like I just don't stream, because yeah, if I stream, what I'll do is I'll just go with the very brute solution, or probably I'll take time and to think. So that's why what I do is before the stream I go through the discussion forum. I check out what people have done differently. Like I take up a problem before, like right before the stream, I spend around 1 hour. I take up the problem and then I think, okay, how can I do this? Can I do like this? And I don't code it. I then go to the discussion forum and I verify if I was thinking correctly. and I just verified. And after that, what I see is, I see in discussion forum who has like which solution is very good or something like that, which is complexity wise or whatever best solution I get. Then I come up to the stream and I tell you that that's where I teach, because I want you to know the best solutions. It's not just about solving, it's knowing the best solutions. So if I solve it over here, then it'll be like, okay, I'm just solving and you're also solving, that's it. So there will be no difference in interview preparation, right? Okay, so has everyone understood this? Perfect, perfect, perfect. Now, how can you reduce the slow by one step? Because slow will start at head, right? In case you want a mock interview, my email ID goes as striver0709@gmail.com. Put in your resume. That should do. War का क्या connection है? Oh, so basically, tomorrow I'll join Google. So officially. So once you join Google, you cannot use terms like interviews, like written है. कर सकते हो, मतलब why take risk नहीं लेने का. So I'll always be like war में आएगा. Like I'll not specifically say like this. And you will also see not using software engineer at Google कहीं पे भी due to those things, because I absolutely don't want to take any risk. Okay. Uh, cool. So everyone's got this. Now, if you store low equal to slow equal to null, Faisal, how will slow move? Null का next null होता है, dude. Null's next is null. Okay. Okay. Got this, everyone. Okay. So complexity big of n by 2. Complexity will be big of n by 2. The length by 2 will be the complexity. Perfect. Perfect. Let's move to the next one. I stream Sunday, Saturday, Wednesday. Okay, I want to read the question. Definite question, Pallo. Read the question completely and then we can get started. Yeah, I need to make keywords for every word, isn't it? Tomorrow I'll put up a video. अभी तुम्हारे stream के बाद I'll record a short video. I'll put it up. It's a good one. This problem I'll spend some time over this problem. It's a wonderful problem. It's a wonderful problem. For everyone who doesn't know binary tree, this problem is not for you. Prerequisite for this problem is you should be knowing what is LCA. That's the prerequisite. How to find LCA. Prerequisite is finding LCA. If you don't know, please don't watch it. So if you don't know, watch my tree series again. Watch my tree series, free ka tree series. Watch my free ka tree series, okay? When are you going to upload DP series? I'm not getting a lot of time. I'm thinking of recording the recursion entirely this. Thinking of recording the recursion series this week. Please read the question. Please read the question, UK, if you have understood it. UK, if you've understood it. UK, if you've understood it. Let's make it 300 likes. Come on, guys. Like 300 likes. Let's make it 300. We have 170 people on stream. 300. Let's have a target of 300. UK, everyone. Everyone's a UK. So the prerequisite is LCA. If you don't know LCA, go to my tree series. Watch out LCA. Learn binary tree, then come across. If you don't know binary tree, please don't watch it. Then don't say ki whatever he teaches we don't understand, because I'm assuming you know binary tree and I'll be teaching in that perspective. Okay. Like kya karenge? Basically it helps. The more you like, the reach ज़्यादा होता है वीडियो का. Okay, someone said 170 में 300 कैसे आएगा? आ जाएगा. बेसिकली कुछ लोग ड्रॉप कर जाते हैं बीच में. Okay, so basically in order to find LCA it's very simple. So I'll just quickly tell you how to find LCA. सर जीमेल पे एक्स्ट्रा स्टोरेज मिल सकता है क्या? नहीं भाई, खुद को मिल जाए. Okay, I'll teach LCA. मैं फटाफट LCA बता देता हूँ. Let's have a quick revision of LCA. How many of you want me to quickly revise LCA? How many of you want me to quickly revise LCA? ओ भाई मेरा iPad आजा. अब मेरा iPad क्यों नहीं आ रहा है अभी? हद है. Okay, cool. This is perfect. Never stop uploading and take you forward. Never stop क्या भाई, बुड्ढे हो जाएंगे तब भी अपलोड थोड़ी करेंगे. Okay, let's understand LCA. Let's understand LCA for everyone who doesn't know, so that we just quickly wrap it up. So what's an LCA? Let's understand. So first let's understand the question. So 5 कितना दिन बाद पढ़ा रहा हूँ आज. I feel like sleeping alone. Okay, so you have a 5, you have a 1, you have a 3, you have a 6. So this is what. So basically they will be giving you a start node. Assume the start node is given as 3. Assume the end node is given as 4. So if I draw the line, this is the start node and this is the end node. So it's like over here, over here, over here. Okay. So the directions they have clearly mentioned. Left means go to its left child. Right means go to its right child. U means go to its parent node. Okay. So over here I can say I'm going upwards, rightwards. So the path is this. This is the path. So for this problem I'll be teaching you two approaches. I'll be teaching you a couple of approaches, but in order to know this, we have to understand the first approach will be comprising of LCA. First approach को LCA रखते हैं, फिर I'll teach you the better way which doesn't use LCA and it's like ऐसे हो जाएगा. Okay, so what is an LCA? So if I draw the binary tree like this, 2 3 4 5 6 7 8 9. Okay, and if I say you that okay, for 5 and 9, can you tell me what is the LCA? So can you tell me in the chat box what will be the LCA for 5 and 9? What will be the LCA for 5 and 9? Can you tell me in the chat box? What is the LCA for 5 and 9? Okay, perfect. LCA is 3. Right, everyone knows what's the LCA. LCA is 3. So this is the LCA, which is 3. So 5 and 9's LCA is 3. Now, how to find LCA? So I'll tell you the very simple funda. So basically what you'll do is you'll go to left and right, and whenever you find either, like, it's an assumption that LCA always exists. On the basis of that, this algorithm will work. So what you'll do is you'll just go left and right, and if you get the node, you return the node, or else you return null. If you get the node, return the node, or you just return null. That's what you're going to do. So let's, for an example, let's start. So you start at 1. Okay, now you can do any traversal: pre-order, post-order, in-order. So I will be doing a simple any like left right traversal. So I'll go to the left and I'm at 2. Okay, now when I'm at 2, I go to the left, it's a null. I go to the right, it's a null. So 2 went to the left, 2 went to the right, it found null. So it did not find any of the nodes 5 or 9. It did not find any of the nodes 5 or 9. So what it will return is 2. Yes, what it will return, sorry, null. What it will return is null. So it returns a null. Now I go to the right, which is 3. Perfect. 3 goes to the left, which is 4. 4 goes to the left, which is 5. Now can I say 5 is among one of the nodes? Can I say 5 is among one of the nodes? And the answer to that is yes. 5 is definitely among one of the nodes that I'm looking for. So over here you will return 5. Perfect. Now you'll go right and it'll be like 6. Perfect. 6 goes to the left, 6 goes to the right, null, null. So 6 did not find either a 5 or 9. So what 6 does is 6 returns null. Now whenever you are standing at this 4, yes, whenever you are standing at this 4, the left guy gave you 5, the right guy gave you null. So if one of them is giving you a node, you take that node and you go back. So you took 5 and went back. Now you will come to the right and it's a 7. You come to the left, it's a 8 and it's a null, it's a null. So both of them will return a null. Now you come to the right, you got a 9. 9 is one of the nodes, so you return a 9. So from the, whenever you're standing at 7, from the left you got a null, from the right you got a 9. So if you're getting a node, you return that node. So return that node 9. Now whenever you're standing at 3, you went left and you came back with 5. You went right and you came back with 9. Now I'm asking you a very simple question. अगर एक जगह पे खड़े हो, left से एक बंदा मिला, right से एक बंदा मिला, which essentially means this is the LCA. This is the LCA, because if you're getting someone from the left and someone from the right, that essentially means this is the LCA. Thereby you say let's return 3. Perfect. Now you're standing at 1, left guy returns null and right guy returns 3. So can I say 3 is the LCA? Understood everyone? Understood everyone? Very quick recap. Very quick recap. Has everyone understood this? Has everyone understood this? Basically LCA node, and assume the first node is U, the next node is UV. So if node is equal to null, you return null. Okay. If node is equal to, like, node ka data is equal to U, or node's data is equal to V, you return the node. Simple. Or else you go to the left, basically go to the left, node star left equal to LCA of node left UV, or you can say node, you go to the right and you get LCA of node right and you get UV. So basically from left and right, if left and right exist, yes, if left and right both you got, then you know definitely, yes, you know definitely if you are getting both, and there's absolutely no doubt, क्या होगा? The current node ही answer होगा LCA. If you are getting something like this, the current node will be the answer. Or else if you are getting a left, you return left. If you are getting a right, you return right या null, जो भी होगा. तो समझ में आ गया कि LCA कोड समझ में आ गया? Has everyone understood the LCS code? Has everyone understood the LCS code, guys? Come on, quick. LCA was very important. So basically, if you are getting someone from the left, you just return it. And if you are getting someone from the right, you just return it. and if you're not getting anyone, you just got this. Fifth line of code, 1 2 3. So basically left you called, right you called. So if you get something from left and right, like in this case, when you're standing at 3, you got 5, you got 9. So you know 3 will be the LCA, because if for someone you got on the left and right, that's the LCA. So I'll return the node, or else either you will get left or either you will get right or null. So either if you've got left, return left, या फिर right return कर दो. null होगा तो null चलाएगा, होगा तो चलाएगा. Okay. Clear? Simple enough LCA code. LCA is clear to everyone. LCA is clear to everyone. Is LCA clear to everyone? Come on, super quick, super quick. बता. Clear. Now, once you've got the LCA, think and tell me what will you do. Yeah, think and tell me what will you do. It's a very simple question. What will you do? So once you've got the LCA, the question boils down very simple, right? So if I just write down a tree and if I give you a start node, 1 2 3 4 5 6 7 8 9 10 11. Okay, so if I give you the start node as let's say 5 and the end node as 11, so can I say if you find down the LCA of 5 and 11, the LCA will be 3. This will be the LCA, and after that the question boils down to saying, okay, from 3 to 5 is a path, and the next path is from 3 to 11. Can you say this? From 3 to 5 is a path, and there's a path from 3 to 11. Can I say this? Can I say this? Yes or no? Because from 3 to 5 will be a path, and from 3 to 11 will be a path. And if you combine them, that will be your answer. But here comes the twist. So you basically need to write an algorithm which finds the path from a node to a given destination node. Agreed? From a node to a given destination. So if you can solve this problem, how do you find a path from a node to a given destination node? I think your answer will be done. Your answer will be done. बस थोड़ा सा यहाँ पे होगा. यहाँ पे तुम क्या करोगे? तुम एक लेफ्ट लोगे, एक और लेफ्ट लोगे. यहाँ पे एक राइट लोगे, यहाँ पे एक राइट, यहाँ पे एक राइट. So ideally should have been left, left, right, right, right. But what you'll do is, for this portion, it goes in upward. So you'll reverse this LL, you'll reverse this LL. Assuming थोड़ा सा change कर देते हैं start node, समझ में better आएगा. Let's change the start node to 6. If it is 6, so instead of going here, you will be going here, which is right. So ideally you would have got left and right from this portion, and from this portion R. Correct? So can I say for left, right, since you know it's like this, the path is like this, so this is the upward direction. So can I say this, whatever is this, everything gets replaced by up. Doesn't matter, because if you're going up, it's gonna be UU. LR will not matter, and this RR will stay like this. So the answer is UU RR. So for the LCA to start, whatever path is, you just make it UU. Correct? LCA to start, whatever path is, you just make it UU, and the other one will stay as it is. Is this clear? स्टार्ट राइट में होने दो ना, तुम्हें क्या दिक्कत है? कहीं भी हो, तुम्हें क्या दिक्कत है? जो स्टार्ट का पाथ है, अगर मैं स्टार्ट को 11 कर दूं, 6 कर दूं, तो ठीक है. तो तुम पहले स्टार्ट 3 to 11 निकालो, फिर तुम 3 to 6 निकालो, क्या दिक्कत है? और 3 to 11 का जो आया, क्या आया था? राइट आया था, तो इसको अप कर दो, और ये क्या हो जाएगा फिर? अप एंड LR रहेगा. तो पहले इसको जोड़ दो, उसमें क्या है? You just need to make sure LCA to start will be up, and the other thing stays as it is. Clear, everyone? Is everyone clear? Start तो कहीं भी हो, ऊपर ही तो आना है. Yes, Ayush has a point. Wherever the start is, doesn't matter. You have to come up only. Right? Okay, everyone's got this? Everyone's clear? Shall I code this? Let's take it 300 legs, guys. Come on. Okay, so I'll write the half piece of code and फिर मैं algorithm बता दूँ. Code बहुत छोटा होगा. मैं बहुत छोटे codes लिखता हूँ. I don't prefer writing very longer codes. Don't worry, I'll write very short code. So first though, let's write the LCA वाला फंडा. So कैसा है इसमें? Tree node है क्या? Tree node star LCA, and I can be like tree node star node tree node star u tree node star v. So I can be right, okay, if node or if node data val is equal to eu val or node dot val is equal to v val, then you can definitely return this particular node as the else as the guy. And if now you go to the left, so you can be like nodes dot star left l equal to LCA of node left u v. You can write node star r equal to LCA of node right u v, and you can be like if L and R exist, both of them are not null, then you can return the then the node itself will be the LCA because perfect. And if L is not equal to null, then you can return the L because then this is perfect. If R is not equal to null, then you can return the R, or else you can return that nothing you got, so null. So this is perfect. This is how the LCA code will look like. Yeah, this is how the LCA code will look like. Now in order to get the directions, I think you have a root, you have a start value. So the first thing that you will do is node star LCA is really, why am I writing node? I'm so habituated by writing the tree series ना. Tree series में हर जगह node था. ये tree node कब से हो गया? लोग tree node कब से use कर रहे हैं? Anyways, tree node star, find the LCA. So you can say LCA comma, you can say start, okay, you can say the root comma start value destination value, and let's return a string and try to print this LCA and see if this LCA is working fine. Should be working fine, but yeah, let's still, I'll prefer checking it once. Start value क्या हो गई? हाँ, integer है क्या? Okay, 5 है क्या इसका? हाँ 5 है, ठीक है, आ गया. So LCA is fine. Now what I'll do is I will basically find the path. It can be something like string find path, string or you can basically say string find path start to LC, path start to LC, start to LC, string path end to LC. Okay, perfect. And now what I can say is I can just call the find path, and I can tell him the starting position is LC, and I can pass him the string of path S to LC, comma, start value, and I can say find path, and I can also find the LC and path E2 to LC. So remember, whenever you are writing anywhere, write codes like this which are readable. Like if you see my code, it's very readable, right? So try to write codes like this which are readable so that it's easier. Okay, so just make sure whatever is it, like I is equal to 0, I lesser than path S to LC dot size I plus plus. No matter what you're doing over here, I don't care. Path S to LC will be on I will be represented with, I'm not sure if this works on up, and you can be answer string answer will be, you can just add it path S to LC plus the reverse. Okay, so I need to reverse it. So basically reverse work करता है कैसे मुझे, path E2 to LC, and let's write it here. I can write begin comma dot n. Okay, should find, and I can write path, and this you can return. So is the code clear? Is the code clear? Is the code clear to everyone? Like I just need to write the find path now. Is the code clear till here? I'm writing such a huge code after a long time, but yeah, it's fine. Okay, it's already assumed that these nodes are present. Okay, like it's assumed that the start node and the end nodes are present in the tree. So I'm assuming that it's already present in the tree, or is it not? Let's see. You're given an integer start value and integer, find the shortest path starting, generate step by step. Is it assuming that we have it? It's not assuming that we have it, but I'm assuming it will be. Okay, why reverse? Arey, it's simple na, reverse kya hoga? Reverse hi na hoga. Because I'll write an algorithm which finds the path from LCA to the node. So if you're going from here, so it's basically like upward, nahi, reverse nahi hoga na. Fix it. Matlab, I'll write an algorithm that finds the path in the opposite direction. Basically, that's why reverse. I'll write an algorithm which finds me the path in the opposite direction. That's why I'll have to write reverse. Tree node star node, and I'm looking for a string. Okay, by the way, I need to pass on the string answer, and I need the target. Okay, perfect. So how do you find path? How do you find path? Can you tell me how do you find path? That's my question. Do you know how to find path? पता है क्या find कैसे करते हैं path? Do you know how to find path? So there's a wonderful algorithm for that as well. So I'll be telling you that. नहीं reverse होगा right में, क्योंकि हम लोग path उल्टा निकालेंगे. The algorithm that I'll teach you will find the path ulta. So let me just tell you how to find the path. So assume this is the tree. Okay, let's assume this is the tree. Again, taking my favorite tree. Assuming I have to find the path from 3 to 12. Okay, assuming I have to find the path from 3 to 12. So what I will do is, yes, I repeat, what I'll do is, I'll keep an answer. Remember this, I'll keep an answer. Okay, I'll keep an answer string, which is initially empty. Now what I'll do is, I'll start at the first point where I'm at 1. And now what I'll do is, I'll call left. So it goes to the left, and remember the target is 12. Remember the target, this is the target, okay? So if I go to the left, I reach 2. Okay, I'm reaching 2. So I go to the null I go to the null because on the left and right there's null. So apparently you did not find a target. So if you don't find a target, you return a false. So whenever you're returning a false, there's no need to store this particular left guy. There is no need to store this particular left guy. Okay, perfect. Let's go to the right. You're at 3. Let's go to the left. You're at 4. Let's go to the 5. Again, nothing. So again, if it's nothing, you return a false. Whenever you're returning false, no need to store anything. Goes here, nothing, return a false. No need to store anything. Return a false because both of the sides returned a false. It's very important to understand. Both of the sides, like neither the left, neither the right gave you true, so return a false. Go to the right 7. Okay. Now whenever you're at 7, you go again to the left, which is 8. Again, nothing, so false. So 8 will not be taken. Go to the 9. Go to the 10. 10 does not have a left, so left will not be taken. But 10 does have a right. It's very important to understand. The guy 10 has a right. The guy 10 has a right which is equivalent to your target. So you will return true. So whenever 10 called its right and it got true, 10 said, oh bhai, I got it true. Oh bhai, I got it true. If I got it true, I will say the right guy can be a part. I'll be like, yes. And thereby I went right. So I will add right to the answer. I'll add right to the answer because I went right. Just a minute. So I went right. Okay. Next, I'll come here. 10 says return a true because you got the answer. You're going to return a true. 9 said, array answer, I got it. So take 10, which is on the left. Right? You can either add on the front, but adding something on the front of a string takes a longer time. That's why we always add it on the back. Remember, adding something on the front of the string might end up taking a lot of time. That's why I prefer adding it at the back. So again, you went back. 9 says go back with a true because once you get a true, there is no need to go here. Again, 7 says I got it true. So this was on the right. So right again. Again, you go back with a true. 3 says I got it true on the right. Perfect. Again, you go back. True. 1 says I got it on the right. So this is how you can easily find the path. कोका-कोला बोतल तो गया, but I got this one. तुम लोग ने बोल दिया तो मैंने बोला कोई बात नहीं, मंगा लेते हैं. So if you add it on the front, it will give you a TLE. Remember, you cannot add the strings on the front because whenever you're adding something on the front, it's a basically shift that it does. Okay, so I could have added it on the front and you would have got the path. तुम्हें path पूरा ऐसे मिल जाता अगर तुम ऐड करते तो. मैं गलत नहीं हूँ, मतलब I'll show you by writing. If you would have done it properly, you would have got the path, but that will give you a TLE. Have you understood this? Has everyone understood this? What I am trying to explain, have you got that? Perfect. कोड लिख ले. बहुत सिंपल है, बहुत सिंपल है, बहुत ही सिंपल है. I taught you an algorithm which finds a path from a node. Now you can just modify that from LCA. That's perfect, right? You can modify that from the LCA. Okay, let's write that in the code. So I know one thing. If okay, मुझे तो मेरे पास तो ये है. I'll take a keyboard. अच्छा वाला keyboard लेंगे. Recommend me good keyboards if you have. ये एकदम घटिया सा keyboard है, देख रहे हो? इस जमाने का है, पता नहीं, पड़ा हुआ था. Basically, if I don't use a keyboard, I have to go down and it be. This is much comfortable. So recommend me good keyboards if you have. So if you get it, you return a true. Okay, you return a true. And now if this node has a left, yes, if this node has a left, and the find path returns a true. Very important. If the find, like, you will go left. Okay. And if this and the target. If this returns a true by any chance, If this returns a true, then I know this can be a possible answer. So you will say answer dot plus equal to, because you went left, so you'll put in left. Okay. Similarly, over here, by the way, if you're getting it over here, there's no need to go right. You can also return a true directly, because you eventually got it right. And over here, what you need to do is you just need to write the same thing, saying node dot right and find path node right comma answer comma target. If this is true, I can say answer plus equal to r. Okay, and I can return a true again. If I did not get in any of the cases, I can definitely return a false. So this is how you'll get it. That's why I reversed. Now, if you could have done this, like you could have said upar aate waqt path lo. You could have also done this L plus answer. You could have also done this. That's correct. Then you don't need to reverse it here. You could have done this, like when you're coming up, you could have taken the path. Then you'd have got the path right from here to here. That's okay. That is still okay, but that will give you a TLE because you're adding something on the front, which means there will be a linear shift of the characters. To insert it at the first, there will be a linear shift of characters, which ends up taking a lot of time. That's why plus equal to is a perfect one. So I'm not sure if it will work, but देख लेते हैं. Compilation error यार क्या? अच्छा अरे जावा ये लिखते लिखते मैं परेशान हो गया. जावा में कैपिटल होता था ना. Yeah, I'm in string the S is capital. That's why I wrote capital. My bad. Okay, perfect. So if I submit this, you see this working. Fine. Oh भाई साहब एक बार में. OP. Okay. So have you understood this? Everyone? Now let's do this conversion and try this now. Now let's see. Now this will give you perfect. This will give you direct answer. If I do this and I'll then just change the, so I'll comment it out. This will also give you the correct answer. Okay, but now see what happens. Here comes TLE. Got it? Why? Because the moment you add it on the front, it ends up taking a lot of time. That's why always backtrack and add it. Okay, got it? ये GG क्या होता है भाई मुझे समझ में नहीं आता है. What is GG? I have heard OG. OG is original gangster, but what is GG? Gone. Good game. Okay, good going. Okay, wow. Acha. Thank you. It's really likes. Come on, let's have a target completed. Okay, so everyone has understood this. Now, what's the complexity? The complexity is you're finding the LC, you're finding the LCA, then you're finding the paths. So it's like 3 traversals of the tree. Can I say it's 3 traversals of the tree that you're doing? Can I say you're doing 3 traversals of the tree? Bhai, how I am able to think like you to solve problem? You'll be able to think like me if you practice. See, I practice, so you also practice. Do explain line number 44 again. So 44 is basically because from LCA to the starting node, the path will not be left, right? If you're going from starting to LCA, start is definitely going to be below LCA. So you have to take upward direction, no matter what. ऐसे लो, कैसे भी लो, you have to take upward direction. So that's why I just replaced everything with U. Because RL doesn't matter. It's like you're going from bottom to up. So it's U everywhere. Got it? Pratush got it? Okay, so how many traversals are you doing? Everyone. How many traversals are you doing? One is the LCA traversal, which is big of n, and there are find paths too. So there are 3 complete traversals you're doing, which is definitely not the most optimal one. So how can I do it better? How can I do it better? Any idea? Any idea on how can you do it better? yeah, I can give you a fair bit of idea. Now what if I say, okay, let's forget about the LCA. I'm not gonna keep the LCA any further. Okay, so I'll eliminate LCA from it. Okay, and I'll just use the find path. Okay, I'll just use the find path, but I'll be smart enough. What I'll say is, Striver, I know one thing for sure. If I find path from the root, if I find path from the root, I know one thing for sure. There will be some part of the path which will be common. Can I say this? There will be some part of the path which will be common. To give you a fair bit of idea, I'll just take the iPad and try to explain you, to give you a visualization. If I do it something like this, if I have like 1 or 2, 3, 4, and then if I give you 5, 6 and 7, and if I have an 8, a 9, a 10, 11, 12. Okay, assume the start is 7, assume the end is 12. Okay, so basically I'm saying this is the starting node, this is the ending node. So if I try to write down the path from the normal stuff, it'll be like right, left, left, right, right. So can I say from root to 7, the path will be like, it'll start from the back end. Like I'll have the path like this: right, right, left. नहीं ऐसा नहीं होगा, उल्टा वाला पाथ होगा. R L L R R. It's a path like this. Can I say this will be the path? And similarly, if I write the path from root to E, which is the end. Similarly, if I write down the path from root to E, which is the end, I will be like right, 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 right. So all rights will be there. Can I say there will be all rights, which will be R, 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 R. So can I definitely say, for this path, this is the path, which indirectly means there will be some portion which will be common. There will be definitely some portion which will be common. And this is the first point where they differ. This is the first point where they differ. So till the point they are common, can I just delete them? And thereby I can easily get the path, which is RLL, which is from here to here, and this triple R is from here to here. This RLL can be represented with U because it's still the starting point, so it can be replaced, and this can be reversed and then can be added. Do you agree? Do you agree? Do you agree? I can just eliminate the common path. I'll just eliminate the common path instead of doing anything different. Does everyone agree? Because there will definitely be a path which will be common. In case of uneven path size, doesn't matter, na? Because even if the path is longer, I'm checking from the back now which portions are similar. I'm checking from the back now which portions are similar. I'm not checking from the front. Got it, Shomal? I'm not checking from the front. Even if it is like, even if I attach something like 100 and there's one more R, how does it matter? R, R, L, L, R, R, and this is like triple. You just matter with the last two, right? This doesn't matter to you because this is the first point of differentiation and this is what matters to you. Agreed? Agreed? Even if I just attach it, even if I just elongate it, if I elongate it to 100, this doesn't matter to me, na? What matters is from the back what I'm matching, because from the back means these guys. Got it? Shall I code? So it becomes a very simple question. I have eliminated the LCA, and what I'll do is I'll say, okay, let's be very frank, let's be like path dot size greater than 0 and this dot size greater than 0 and path this dot back, the last element, is equal to make sure if you're giving in एक second, come on sir, make sure if you're giving in what to say, war या फिर interview जो भी है, तो वहाँ पे थोड़ा सा just make sure you write quotes like this. Okay, like naming conventions should be clear. Okay, so you can be like dot pop back. I give it S to L, so I can just copy paste this. I can do a pop back again. So that will make sure the last stuffs are gone, and after that I can reverse and then add it. This should be fine. URL, and then I submit. If start equal to 10, doesn't matter. If start equal to 10, even if start equal to 10 and 12, then what will happen? ठीक है ना, क्या ही जाता है? You will take sorry, if start is 10 12, na, you're saying 10 12 doesn't matter. They'll be like R for this guy, and for this guy this will be 4 hours, so 4 hours will go off. 4 hours going off, there will be only R. That's correct. The answer is correct, right? So what are you observing when I'm writing a code? As Utkarsh said, are you observing that my codes are very clean, very readable? Like, do you agree that the codes are very clean, very readable? And this matters. Trust me, this matters in an interview. Like in all my Google interview, like मैंने जितना भी दिया 4 rounds, everyone gave a feedback that his code is very, very clean. So it will matter if you're giving an interview, okay? Please try to write codes like this which are readable, super clear. Names like path, start to LC. Like now it will not be start to LC. You can just replace with start to root. Start to root will be the path. But I just make sure you write the codes as clear as possible. That's the agenda of Leetcode. Okay, so we've done it using a couple of ways. I hope everyone has understood. Okay, so let's do the next question. You have to know Eulerian path. You know how to solve this. This question can be done with Eulerian path. If you know that, it's a very, very easy, like simple DFS. Simple DFS will do this problem if you know Eulerian path. Is this important? It isn't important. Like you can skip the problem if you wish to. It won't appear anyway. Never ever asked. So time complexity will be big O of 2n plus the common portion. So you're basically avoiding 3 complete traversals. That's it. So it's a better one with that. This will not come. Is Google outside India easier to crack than Google India? Doesn't matter. The interviewers panel same यार. Even if you give a Google India interview, the interviewers are from Germany, Europe. Like उनको बोला नहीं जाता है कि यार ये इंडिया से इसको टफ पूछो, यार इसका यहाँ पे होने वाला इससे टफ पूछो. There is nothing like that. It's depends on your luck who is taking the interview. It's completely luck based. Because generally for all people who are working in India, like for me, I had office hours till 7 p.m. So all my interviews were scheduled late in the night at 9 o'clock or 10 o'clock. So at that time, Germany people were available. If I'd have given 10 o'clock in the morning time, probably some other country would have been available. Depending on your availability, interviews are mapped to you. And you cannot say कि बाहर easy होता है. It's nothing. Like whenever you are going to give an interview, they don't even know. They just told ki you have to take a DS algo round, so you ask a DS algo question. Apart from that, they don't even know where you're applying. Nothing. So doesn't matter. This will not come, but I'll not be teaching Eulerian path. You can learn Eulerian path. I'll just be solving this problem. I'll be teaching Eulerian path. ये बहुत बड़ा concept है यार. It's a huge concept, Eulerian path. It will take me 50 minutes to teach Eulerian path. So if you don't know Eulerian path, you can watch out some videos on YouTube, or you can I read it from here. I usually read it from here. CP algorithms. Like you can read it from here as well. I read it from here. Yeah. This is the common logic. You can just go across, read it. पूरा पढ़ सकते हो. बहुत बड़ा है. 50 मिनट लग जाएगा. अगर मैं पढ़ाने जाऊँगा तो that's why I'll not go deep. As we have traveled today, so I'll just code this and sleep. I'll code this and go to sleep. Okay. So valid arrangement of pairs. So what is the questions? Please read the question, give me a UQ. I'll start in a couple of minutes. Please read the question, give me a UQ. I'll start in a couple of minutes. I am sleepy. मैं ट्रेन से आया तो मुझे बहुत ज़्यादा नींद आ रहा है, तो मैं ये करके फटाफट सोते हैं, ठीक है? Let's understand the question. The question says you're basically given a zero index 2D integer array. Okay, pairs, where pair I means a start and an end. So assume these are given to you. So you'll be basically given some pairs. You have to arrange them in such a way. Yes, I repeat, you have to arrange them in such a way. Like if you see the arrangement, this 9, the ending of the previous guy is equal to the starting. Again, the ending of the previous guy is equal to the starting. Again, the ending of the previous guy is equal to the starting. So you have to arrange the pairs in such a way that the ending of the previous guy is equal to the starting. And you can return any valid arrangement of pairs. If there are multiple pairs, you can return any of them. Questions clear? Is the question clear? Is the question clear? नहीं आया क्वेश्चन क्लियर नहीं हुआ क्वेश्चन नहीं क्लियर हुआ Is the question not clear? Then I'll take UQ everyone. UQ or not? Okay, so assuming UQ. ठीक है it's like you have to just arrange the pairs. You have to arrange the pairs in such a way that they are so 5 1 4 5 11 9 9 4. Arrange the 11 9 and 4. So basically this is given to you. So once you arrange, it's like 11 9 9 4 4 5 5 1. So if you see this 9 is equal to this 9, this 4 is equal to this 4, this 5 is equal to this 4. So the end of the previous should be equal to the start of the current. So for this is the start, this is equal to the end of previous. This is the end of previous, start of current. So this is what the question states. Okay. So how can you solve this problem? Now, whenever you see edges being connected, the first thing that comes to my mind is definitely a graph. So what I'll do is I'll convert this into a graph. 5 has a directed edge to 1. 4 has a directed edge to 5. 11 has a directed edge to 9. 9 has a directed edge to 4. So if I connect this via graph, I can say that, okay, I can probably, so if we write down the Eulerian path of the graph, it's known as Eulerian path. Eulerian path, if you write, what does this states? A path in which all edges are visited, but only once. So over here you can say a path from 11 to 9, 9 to 4, 4 to 5 and 5 to 1. So this can be called as the Eulerian path, where I say this is once, this is once, this is once, this is once. This is what we call as Eulerian path. So if you don't know Eulerian path, you cannot, no, this won't come. Ye koi nahi puchega. Like if you are not willing to listen, you can drop off. Ye koi nahi puchega. But I'm just solving it for the purpose of solving it. So if you for this problem, if you just print the Eulerian path, it's done. You don't have to do anything different. If you just print down the Eulerian path, your job will be done. कुछ अलग नहीं करना होगा. If you just print down the Eulerian path for this graph, like create the graph, print down the Eulerian path, and you should be done. Okay. So if you don't know Eulerian path, please watch it out. ठीक है. So अभी Eulerian path कैसे निकालते हैं ये तो बाद में आते हैं. अभी 2-3 और edge cases देख लेते हैं. Is it only Eulerian path? First thing is it's always possible. So if they're saying it's possible, then there will always exist an Eulerian path. Okay, so let's take this example of 1, 2, 1, 3 and 2, 1. Okay, so if I take this example of 1, 2, 1, 3 and 2, 1. So over here, the Eulerian path can be from 1 to 2, 2 to 1. Like you can go from 1 to 2 and then from 2 to 1. So this edge is visited once, this edge is visited once, and from 1 to 3, this edge is visited once. It's not about the nodes being visited multiple times. Eulerian path states every edge must be visited once. Okay, so Eulerian path has a very simple funda. If you read across, Eulerian path says you start with the node whose out degree minus in degree is equal to 1. You start with that particular node. Now in order for Eulerian path to be possible, it states there will be one node whose out minus in degree will be 1. There will be one node whose in minus out will be 1, and all the other nodes, yes, all other nodes will have in equal to out. That is what Eulerian path like. An Eulerian path is always possible if these conditions exist. If an out degree minus in degree is equal to 1, if an in degree minus out degree is equal to 1, and if all the nodes have in degree equal to out degree, then I can say an Eulerian path exists. But we do not need to check for this because they have already stated that an Eulerian path is possible. A valid answer is possible. Thereby what I'll do is I'll just start with the node where the out degree minus in degree is equal to 1, because Eulerian path states it always starts with this particular node. Okay, and whenever you do a DFS in Eulerian path, if you read across, it's basically you just call the DFS, and what you do is whichever DFS you're calling, you erase that node. Yes, you erase that node, and if at a point there is no other nodes to be visible, like whenever you're coming back, just make sure you take that node and put it across to you. That is what you always do in Eulerian path. So you can read it across. मैं बहुत deep में नहीं जा रहा हूँ. You can read it across from CP algorithms. It's a very vast algorithm. बहुत proofs है इस पे. And read it across. I'll simply code this off. So what I'll do is I'll create a private of vector of adjacency list. So what I'll do is I'll create a adjacency list. Probably I can do a map int of vector of int of adjacency list. And what we can do is we can definitely iterate across the pairs, and I'll be like adjacency of it.first can be set as pushback. Remember one thing, guys, it's a directed graph. So please don't mess it up. Directed graph है तो mess up मत करना. So I have made sure that I just make pairs with it. Okay, so make sure you make the graph with it, and right after this what you can do is you can have an in degree as well. So in degree के लिए you can definitely keep something like a map of int comma int or so by the way unordered map just to avoid TL issues. And over here you can again take unordered, and you can take an in degree. And also the out degree. So over here I can say that okay, in degree of it1 will increase, and out of it0 will increase, and at the end of the day I just need to find out which is the starting node. So I can keep the starting node as -1. For I can just go across and iterate on the one of the nodes that can be called as in degree पे iterate कर लेते हैं, and I can say if the in degree of it dot second is out of in degree of, let's iterate on the nodes as well. So if I'm iterating on the nodes, how do I iterate on nodes? One of the ways is I can just iterate on the adjacency list so that I can get all the nodes. Yes, I'll get all the nodes for sure. And what I can do is I can say if the in degree and out degree is if the out degree of this node, which is it dot first minus in degree of this it dot second, it dot first again, sorry, it dot first is equal to 1, and I can say this can be my start node, which is it dot first, and I can definitely break out. And over here what I can say is if the start is equal to 1, then the answer will be the pairs. If there is a single node, will there be an in degree out degree? Let me think about this. If there is a single node, अगर एक single node है तो क्या एक in degree और out degree होगा उसका? Like अगर कोई, if there is a single node, okay, it will still have. But is there a case? There exists a valid arrangement. Is there a case where I'll not find the pairs? Let me think about this. Is there a case where I'll not find pairs? In case I don't find it, is there a case? Is there a case? Like, can I think of a case where I'll be like, okay, this doesn't exist. Like, I don't get someone minus someone. Yeah, there might be a case where it's in circular. Like ऐसा case पे हो सकता है 1 2 and 2 1. In this case it'll be like 1 goes to 2 and 2 goes to 1. So it's a circuit, it's a Eulerian circuit. So in case of circuits, there will be no nodes which has out degree minus in degree. So in that case you can start off from any node. Yes, in case of circuits you can start off from any nodes. So what I'll do is, if it's a circuit, I can start off from any one. So I'll be definitely like pairs of 0 0 will be my starting point. Okay, perfect. Pairs of 0 0 is my starting point. Then you can write the DFS and you can say I'll start from here. And do I need anything else? I don't think I need anything else because the adjacency list is globally declared. And I can write private and I can write void DFS int node. Yes, perfect. And now what I can do is I can say for not. मुझे erase करना है. So if I'm doing an erase, I have to iterate on this map on adjacency dot size. Yes, adjacency size equal to empty. If I'm iterating over here, and now I'll be like, okay, I'll have to go here. So adjacency of last guy will be thrown out. No. The next guy will be adjacency of node dot back, assuming I just take it off, and I can just pop back adjacency of node dot pop back. We have 131 watching. 131 क्यों कर रहे हो watch? Like, do you have an idea about this? That's basically you iterate simple DFS. You take the last element, you take it off, and then what you do is you call the DFS for the next guy, and whenever this comes back, you just store it into your answer. So probably you can put an answer as well over here, like or you can just carry over here. Confuses अरे नहीं समझ में आएगा अगर Eulerian path नहीं आता तो नहीं समझ में आएगा इसलिए तो that's why I'm not focusing on teaching so much. Like, why am I doing such like this is so that you go and read Eulerian path and you come back to this video and you see the code. That's why I'm teaching. Otherwise I'm not taught. So that you go across, study Eulerian path, come back and इसको देख लो. You can use whatever you wish to. You can use. Okay. So next comma answer. Yes, perfect. And probably I can just keep an answer over here. The only reason I'm coding is so that you can go back, watch this, and come across and check it out. That's why I'm coding it. So that बाद में आके you can solve it. Okay. this is kind of, I can say, not that important. Like that's your choice. उल्टा आंसर आ जाएगा शायद at the end of the declaration list. यूलेरियन पाथ मुझे मिलेगा, लेकिन मुझे उल्टा प्रिंट करना है. कंपाइलेशन है empty. Okay, so if I just do this, should be fine. रिवर्स करना पड़ेगा मोस्टली. यूलेरियन पाथ उल्टा आएगा, उल्टा आ जाएगा. आहा, ये आंसर. Why did the answer come back as 0? Let me check this out. Adjacency. ज़्यादा आंसर केम उल्टा, तो जस्ट रिवर्स कर दो. यूलेरियन पाथ उल्टा आएगा start to end, but you need the opposite, so you can just reverse. Answer dot begin, answer dot end. It's a competitive programming topic, तो इसलिए मेरे को पहले से आता है. If you don't know it, पढ़ लो, हो जाएगा. बहुत सिंपल है, कुछ नहीं किया. मैंने बस Eulerian, this is the code to print Eulerian path. That's it. Prints Eulerian path in circuit also. Prints the Eulerian path. That's it. It's a simple code. Like if you know competitive program, if you have done competitive program, it's a very simple one. What you do is you go to the next adjacent node, you clear it, जिस तरह जा रहे हो उसको हटा दो, and जब वापस आ रहे हो उसको स्टोर कर दो. As simple as it can get. Accepted. Perfect. Eulerian path इधर से पढ़ लेना. ये यहाँ पे फाइंडिंग Eulerian path इधर से पढ़ सकते हो. और कोड कुछ someone, but वो इंट्यूशन नहीं पता था. That उसका नाम क्या है यार? विलियम विटसेट समथिंग. उधर से पढ़ सकते हो. But hey, if you read this blog, you'll understand this. Read this, but ये थोड़ा सा टफ कर दिया है मुझे लग रहा है. हाँ, yes, complicated stuffs. अब सेम ही है, इधर भी पढ़ सकते हो. You can even read this. DFS से नहीं किया शायद इन्होंने कुछ, मतलब वीडियो देख लेना. विलियम का देख लेना वीडियो, ये अच्छा पढ़ा था. उसका वीडियो देख सकते हो. उसका वीडियो देखोगे तो हो जाएगा, आई गेस. विलियम फेस्ट. You watch this video, I think that should be good. थोड़ा फास्ट पढ़ाता है तो देख लेना. एंड इंट्यूशन यू माइट नॉट गेट, सो जस्ट थोड़ा सोच लेना. विलियम फिटसेट जो भी नाम है, check him out. And after this, check out this code. That's a very simple one. This is for Eulerian circuit, where you can start anywhere. Remember, this is for, like, you can start anywhere you wish. This is for Eulerian circuit, because in circuits you do not have nodes who have out minus in equal to 1. So that's the case. This is for Eulerian path. Find the first node, find the starting node rather. Here's the properties. Yeah, I'm using external keyboard. Here are the properties that you can use. So for Eulerian path, this is the property. For circuit, everyone okay, perfect. Cool, got it. Got it, everyone? Okay, so That should be it from my side for today. I hope you enjoyed the session. The complexity for this is very simple. For pairs, big of n, and again for adjacency list, big of n, and DFS big of n plus v. So near about linear complexity. ठीक है. रिकर्शन आ जाएगी यार मंडे टू. कल मैं फ्री हूँ. कल तो मैं ज्वाइन कर रहा हूँ. कल रात को फ्री हूँ. कल रात को बैठ के रिकॉर्ड कर दूंगा. एंड होपफुली आई विल गिव यू सम सुपर क्विक. इंस्टा डीएम यार, इंस्टा डीएम मेरा कुछ पंगा चल रहा है. पीपल मैसेज बट मेरे को आता नहीं है. मतलब वो बहुत दिन बाद आता है, पता नहीं क्यों. आज भी कितने लोगों का ऐसा मैसेज बहुत दिन बाद दिखा. हाँ sir, it's more than like you don't need to read Eulerian path. It's not important. If you still want to read, you can read it. Like I knew it because I used to do CP. In CP you know about all these stuffs, but it's not necessary over here. You can ignore it. Okay. You can chat on Telegram. अरे एलसी तो कुछ ही पूछता है. This might be as in good companies. You never know, right? But I'll not, like, if you see in a longer run, I don't see this question gaining a lot of I don't see this question gaining a lot of क्या बोलते हैं likes and dislikes वाला फंडा होगा. If you carefully see this, the likes is already 77-88. I don't think this will be very famous question going forward. Okay, cool. Yeah, you can ignore. Like whatever I've taught in the graph series, plus Bellman-Ford, plus Floyd-Walsh, that should be more than enough. Okay. Cool. Okay, guys. So I'll take a leave. Let's meet Wednesday. On Wednesday, I'll be definitely solving this problem set. Whatever problem has been coming across, house rover, odd even linked list, maximum product subarray, stream of characters, all the problems that will come till Wednesday. From Wednesday to Wednesday, whatever problems come in, I'll be solving all. And we make a pattern that on every Wednesday, all the 7 problems that I've come across, I'll be solving. I'll be live solving them. I'll be teaching different ways. So yeah, you can also solve with me. So that 7 प्रॉब्लम ऐसे करके हम लोग वीक मंथली 30 प्रॉब्लम करते रहेंगे. एंड कॉन्टेस्ट से 16 तो 50 प्रॉब्लम तो मैं ही करवा दूंगा तुम लोगों को हर मंथ. ओके, फ्लड वर्शन मैंने इधर पढ़ा दिया, इधर देख लेना. ओके, 50 प्रॉब्लम तो आई विल ऑलवेज मेक यू डू. ओके, cool. So I think that should be it from my side. Good night, guys. Bye bye. Take care.